this BRE also. So in this classic example, so there are certain stacks as controller and how it is working behind the scene, how discovery is being done, and all those things. But this is the basic example. So in this example, in the background, it is using a higher function, and that function is basically creating a method just to push that data. So in that data, if it is creating a method those things is being done in this object or this class, and that class takes care of all those things, all those complexity that I yesterday also I told that there are some various API, higher API. Once your system get complex, then company provides the API or classes for each thing to make the job of the firmware developer, the software developer easier. So over here, this particular class contains all the codes we are needing, and we are just instantiating it and with the just begin. So this will just begin part that once you start the pairing part and go to the Bluetooth profile searching mode, you will see this name. So that name is being provided over here, and this will go to this object. And if you see if that is being connected and if some device is being connected, then we can basically check for the incoming data. So I will also explain how Android phone or Android software development can be used for this sending and receiving the data over a serial. So you can take it as something like the serial or RS-232 serial connection that we are doing in the embedded system, and this is the more or less exactly same profile. It got some baud rate. There are certain baud rate by specified by different manufacturers. For example, Microsoft has some 57600 or certain in the certain different kind of devices. They have the set baud rate, and those kind of system, those kind of libraries are being provided. And if you see the Windows, it is being it will be this particular configuration is in the OS only. The same is with the Ubuntu. So we can basically just receive the incoming call, and if this is 49, 49 goes to the SKI, it goes to 1. So the if the user is sending 1, then what I want, I just want to turn on the LED. So this is the LED digital red normal Arduino operation, and this LED on the our hardware we can see in the this pinouts that second pin is connected to our LED on the onboard LED. If we push this code and we use an application to send 1, then that 1 will turn on the LED, and this will return this LED turn on. If we send 0, that is the 48 value, 0 in the ASCII, and that will translate to the int of 48. Then it will send the low, and the device will reply back with the LED turn off. So I will just push this code, then we will see this screen of pairing. Then you will pair, then certain you can come use an app. Basically, that app link is also provided. So there are many serial applications, serial Bluetooth applications that is being provided and available for free on the Play Store. You can also create that, but again, that is a certain other complexity. We don't want to go into that. So currently, I will just use this existing app, or you can develop your own app to communicate very easy and easier functions provided by Android SDK. So you can use that to basically search for it within the app. So within the app, you can see we have this target uh, name that is being provided. This LED control we had given over here. So whatever we have given in this line, that will be used over there for the devices to discover. So when I discover it and I just pair it, so earlier it is not connected. When I will just press this button, it will connect to the device, and once done, it is connected. So if I will send 1, my device LED will turn on, and when I will send 0 and press this button for sending, then I will receive the LED turn off, and I can do this again and again. So what the idea behind this thing is that you can have a bidirectional communication with the device in the point-to-point communication. So in the Bluetooth Classic, we are going for the point-to-point communication, and in that manner we can fetch the new data. We can get we can basically set some values, or we can make the device to perform some action. So this is about the classic Bluetooth example. This is the Bluetooth 2.0 example, and all the codes are provided in the repository or on the website, this website. Okay. Now we are going for the Bluetooth low energy, and what profile it is and how much low energy it is consuming. So all those data are provided over here. And we have also used a simple example just to demonstrate a simple device uh, application. So if you see in the BLE part, you must have, I'll just start with a demo example. You must have seen this kind of device or being used. This is a website, a London-based website. Indian brands are also available, in which they just basically connect it to some device. So this thing runs on the Bluetooth normal cell powered Bluetooth CR2032 battery and those kind of battery. And you just put it in your wallet or in on your keys or on in the car or on your the tag of your dog collar. So you can just place it over there, and these devices are able to
I hope ki sir has disconnected. So sir has connected again. So sir will now share his screen. Sir, you can now share your screen and you can now unmute yourself also.
Am I audible?
Yes, sir, you are audible, sir. You can just share your screen now. Yes,
Yeah.
sir. Now it's visible, sir.
Sorry. Yeah. Yeah. So I was talking that you must have seen these kind of devices on the Bluetooth, where they basically use it for the tracking. So it is so low powered that with the coin cell, it works for a year or two. You can use these devices for basically with respect to their relative strength of their signal. We can reverse triangulate the exact location. So if more than one or if you can see more three basically 5, 6, or 10 devices more are there, and if there are 10 Android phones, so you can basically reverse triangulate the location of the something that is transmitting um, uh, that name or that particular device ID. So you can basically reverse triangulate it, and this is the mechanism on which these products are developed. And this product is common in UK and in US also. So where they use this kind of track to basically keep track of their devices. So the working principle is that each BLE will basically after a certain interval, it will basically broadcast its number, its values, or its ID, and with the RSS strength of the device, we can basically reverse triangulate its exact location. So I have basically created the same code in this hardware in which we are basically on each button press. Example, it requires that you send a message, and that message should not be something like it is basically requiring pairing or something. It is just broadcasting, and whosoever can receive that message, that device will receive that message, and how that data is being interpreted, and what is the data is that device is sending. So we have to basically decrypt that, or according to our logic, or if some encryption is being done for securing that data, you can also do that. So with respect to device ID, you can basically receive that data. So in this example, what I did, I basically use this to basically broadcast, and whenever a button is pressed, so if you see in the camera, whenever this push button, yeah. So whenever I will just press this button, so this device will change its random number. So in the use case of this device, that particular device is basically sending a unique number with respect to each unit. So with that unit, we are getting over here the relative strength of the device that is being transmitted by that unit. So we use this unique number and their transmission level, their transmission power to reverse triangulate it. And if you just push the data, and you will install an RF Connect, again open source app available on the Play Store. And if you see that on connection, after connection, whenever we will press this number will change. It is broadcasting a unique value that can be received by any number. So this is the another kind of M2M, machine to machine, or if some other tracker is basically receiving this, or some other module is receiving it, not mobile phones, you can in this way these devices can communicate data. So this is another example of a PicoNet in which one-to-one communication is being made. So I will also demonstrate to you a mesh kind of network in which there is a very attractive project of mesh plastic. In the free time you can just explore this. So this project is basically using the LoRa network. So each LoRa module basically have 1.8 kilometer of the range, and with this hardware, our hardware, you can basically communicate in the mesh network like 1.8, 1.8, 1.8. So if even you are in the forest region or some area where you want to deploy some sensor, so with this kind of mesh network and with the simple low power lipo batteries and low, basically any kind of battery or any solar powered unit, you can communicate to that much of the range with a very small fraction of power. So that is also possible. And in the Bluetooth also, I have described the Bluetooth mesh. So in that Bluetooth mesh, you can use this for this kind of communication in the mesh topology. So again, our target as the agenda is what how device communicate, what are the different topologies, what are the different network interface card. So in the current scenario, in the current example, we saw how Bluetooth Energy is broadcasting it openly, and what are the application of the devices that people are making from this kind of unit for like this is the one example of tracking, that reverse tracking that device are made. And in the India, it is not that much popular, but in outside, this kind of devices is very popular. So now coming to the LoRa part, that LoRa long range communication, that trademark of Semtech. So this communication is basically on the physical layer. We use something like FSK, frequency shifting kind of thing. It is not exactly that. It is something called chip modulation. So they use this chip modulation to communicate to the long range, and in that long range, basically, they communicate on different bands. So in India, we operate from the 865 to 867 megahertz specifically. There is a proposal being forwarded by the TRI in 2017 of making this 868 megahertz also available in India, though it is not in use currently since the inception, especially in the India for any particular industrial or medical use. So it was a proposal basically proposed by the TRI to use this also. So if you see what is our standard are on the terms of the bands, and ISM bands are very similar to that of the Europe. So if you see in Europe 865 to 868 megahertz band is in use for the LoRa band or LoRa communication, that is free to use for the power that is applicable with the LoRa module. So you can use it to free for other bands. For example, certain bands, if you take for example 890 megahertz or some are higher bands of 12 megahertz, 1100 megahertz, 1200 megahertz. These bands are restricted. These are for the 2G spectrum over there. The government allocate it to or provide it to the various people for certain time period. But these bands, 865 to 867 megahertz band, are freely available for the industrial as well as the personal use. And we in this LoRa module, we are using that. If you see in the video, you can see this is that module and this is that antenna. This antenna is particularly tuned for this particular 865 to 867 megahertz, and you can use that. And you can also use 868 in that proposal, but that proposal is not finalized, or some concrete decision are being made. So people also use that, but in the some there is not written uh, guidelines by WPC or try to start using it for the industrial purpose. So that is another thing. So we will use that. So we are basically provided this example of LoRa sending and LoRa transmission from the sender to receiver. It is point-to-point communication that we are demonstrating. You can also, as I said, that you can also use this code. That code is also in the repository. You can use this code for mesh network also with the device. Currently, we will demonstrate the point-to-point communication. You can test it with the range of around 1.5 kilometer if it is open, and if in the urban areas you can easily get around a kilometer of range. So in the colleges we tested Dwarka, so that NSIT region is very open area. So we tested it over there. So we easily get the 1.2 kilometer of the range in the urban area, and as well as the antenna is not also placed at the very high location or something, because for the fractional transmission we need the antennas should be in the proper height, so that we can fully utilize the transmission power being transmitted on the receiving side. So we can easily get that. And this is the sample code. So very simple code. I just mentioned the pin number with respect to our mapping, and we provided a sample code. We just started the communication as SPI, communication serial peripheral interface, kind of communication on which this board is communicating with the LoRa unit, and that is basically sending simple hello packet or something. You can also in the rural part, you can also communicate for sending the moisture of the soil or certain other parameter from in the fields. Like you can easily get 4.5 to 5 kilometer of the range if you place it well. And you on the center part you will just send this, and it is a receiver, it is a callback function. So when callback function means whenever there is whenever we will receive data, so it will give us a callback to a certain function. So whatsoever is our function, it will be called on receiving of the hardware. So if our LoRa hardware receives something, so on receive it will call this function. We can name anything. On receive we can call this function callback or something. So whenever our hardware will receive any kind of data, it will just call back this with the packet size and what it receives. So we can again just read that data. We can basically do the conversion, and we can just print it. So whatever we will print, we can also see the what strength we are receiving it. So if two devices are very close and if two devices are very at long distance, so what is the relative strength of the signal I am getting and what packet I have received. So if you see on the receiver side, we are getting hello 6162 because we just incremented it. So you can replace it with the data of sensor data or any kind of other data and communicate to the base unit, and that data will be printed on the serial. You can use this data for other storage of this data or something other things, performing actuating something based on this data. So you can do that. You can also, so this is an example of point-to-point communication in such a long distance. No Bluetooth can work for a kilometer or this kind of thing. So therefore, getting data that is away from the premise, or you are doing some experiment or research work where the target is placed at some distance, and you want to fetch the data. For example, in the drone, if you want to receive the sensor values, then you can use this kind of LoRa communication. And since that device is in that target is in the air, so you will get a very good range. So people also demonstrated it like satellite communication from this kind of LoRa module, like satellite to base station. They are using this module to basically send the data. So the bandwidth is 125 kilohertz. So it is not apt for the transmitting the video for sure. If you are thinking that we can use that for video part, that's not the case. But you can easily use it for the sending the basic sensors value. So you can get the data from one unit to another unit. So in the video, use these two data and these two units, and these two units are basically transmitting from here to here. But you can also place it at the long distance to basically get these values. So this is the LoRa communication. So LoRa is a simple something that we are using on the physical layer. So if we talk of the OSI model, so we are using at the very rudimentary form. Like we are not creating networks. We are using it for simple NIC to NIC communication, and it taking into consideration that we for this particular example don't need to perform some kind of network. So if you want to form a network from this NIC, from this physical layer, so we can use the LoRaWAN. So LoRaWAN is the low power wide area network. So in this module, that requires a uh, central LoRa server in which this kind of device basically just transmits, and the central unit basically receives. So we place the central unit at a very good height, so big building or mountainous region, we are at the top position or some tower or something. So we can easily get around 4 to 5 kilometer of the range, and that central unit can form a network. So this is a wide area network in which the physical layer is the same. So whatever we have used in the LoRa communication, that communication is at the physical layer. So we have used the very same physical layer for creating a network, for creating application layer, for creating transport layer and all those things. So these devices are widely used, and in the Europe there is a big boom of it. So if you see these IoT communication, so in America there is a widespread use of the LTEM. So that LTEM is very much popular over there. Over there they use 915 megahertz or in such kind of bands for the this kind of communication. Since our in India we more or less more close to the standards and practices in the Europe, being back way back from the colonial period. So what a band we are using, so that market is very close to that of the Europe. So whatsoever we are purchasing, or the pricing factor and all those things are being very close to the European market. So this 865 to 868 megahertz band NICs are very easily available and at the very much cheaper price, because there are many colonial countries, they have the very same standard. So there is a very big market of this particular band. So whichsoever ICs and ICs we can easily get at the cheaper rates, it's because it's only directly depend on the market. So जिनका मार्केट जितना बड़ा है उसका प्राइस उतना लाइक कम हो जाता है. So we are very close to the this part. So there is another thing in the competition of the LTEM, that is that LTE or 4G subset of the 4G technology. LTEM they use it for the machine to machine communication. It is more popular in the America, but there is an alternative of the NB-IoT, narrowband IoT, in which they basically use the selective bands of the 4G networks for the LTE network for the transmission of a very low small payload of this end-to-end communication. That is still in the testing phase. So last 2 years back also and last year also, even Vodafone and Jio announced that they are using it for they are basically testing. But currently the NICs are not readily available in the market, and since that market is not very much grown, so whatsoever NICs of the NB IoT is available, they are costlier comparatively as per current situation, and no one has rolled out for the open market or commercial market in India. Neither Jio, neither ATAL, or nor this Vodafone phone has released this in the open market for the everyone to use. But yeah, that is the another use case that will be dwell in India very recently. Maybe in 2021 we will see this rollout of NB-IoT for normal public to use this kind of device, and the monetary segment of that will be also such that they will not charge much, but the pricing of the NIC, that network interface card, is subjective. We will have to see that what pricing that NIC will be available. So so that network is in the competition with the LTEM and the LoRaWAN. But again, LoRaWAN is more popular and is an open network. So for that, you are always for NB-IoT, for LTEM in US, for NB-IoT in India or European side, you are dependent on the carrier provider like Airtel or Jio or Vodafone. So again, you are dependent on that network should be provided in the remote area also. But that is not the usual scenario, because they don't place their LTE these things at the very remote locations. Uh, in the forest, very remote forest also, these kind of network are not available there. So we need some long range solution that can be that we can plot it over there. So LoRaWAN or LoRa is a very good candidate for this kind of application, in which we basically place uh, our own network. We establish our own network. We just create longer and longer range, and from one of the node in the mesh case, from the one of the node, you basically transmit the data to the cloud, because that cloud is in the that last node, or the node is in the vicinity of some other network. So you basically make a bridge from this network to the your normal Wi-Fi or normal network. You just for the communication. But with the LoRa, you can create your own network. So with that network, you can basically you don't have to pay to anyone else for using that network. You can use that, and you can relay the information, and you can basically bridge it at one of the nodes to basically communicate back to the server. Or if in some scenarios, if you have the server in the remote vicinity only, then you don't even need the bridge. You can just create your own network and you can just grab the data. So this kind of connectivity helping that in creating the bidirectional private network. And there are many open source projects to support you. For example, this chip stack, this chip on the basis of chip modulation, this particular this thing has developed, and it is widely used by many corporate solutions to create your own network. The other option is very popular option is CTN, the Things network. It is again gained popularity in last 2-3 years, and it is widely used in the European part. You can easily see the also in the India, you can see their coverages. They have certain maps on their website demonstrating where they have placed their gateway. So like this much gateways they have available. You have to just buy IOTA sync or singular device. Just you have to just to place the code, and you can get the data on this server for free. So they have the two edition. One is the enterprise edition, another one is the community edition. So on the server of this, you can use it for the free, and you can see that this much kind of networks are available for free, and this is secure also. It is not that if you use some other gateway for transmitting data to the cloud, then it is not secure. It is properly secure. It is properly encrypted. I will also demo you how encryption is being done in these kind of devices, IOTA sync and ESP32 devices. But the point over this section is that you can use any of these gateway, which is basically transmit data to the cloud. And like this is the you can see the congestion of the gateway. Like you just buy it and you are getting a network for free to basically send to the cloud and use it. So it is very much popular in Europe, in widespread, and since the colonial time we share the same standard. So you can see that in India also it is being widely available, and people are creating their own network in different places. So this is widely, even the China is using that, but the China is using their own private network and created the similar stack. They are not using the Things network. They have created their own for widespread water metering system and electrical system. They are using this kind of network for basically communicating it. So this is another aspect of it, of the LoRaWAN. So the band there, the China uses for 33 megahertz. Even in India, when we see this kind of band, it is widely used in the your this car RF key of your car to open it. They use this band for certain power level. That is allowed, but not for that. But India, for the LoRaWAN, for China, in the LoRaWAN they use this for 33 megahertz. In India, we use 865 to 867 megahertz. 868 megahertz is also available, but no final regulations are released. But in you can see in the this Europe, this 865 to 868 megahertz band is used. And if you see the overall map of the world, so you can see that whosoever was the colonial time partner of the Europe, you can see that that is being popularly used over there. And this network is openly available in the forest, in the mountain part, on the this sea level and sea, and you can use that. So that's the all thing about the LoRa. And there is also this physical layer, as well as there is a LoRaWAN code available, but that WAN code needs the central gateway for its deployment, and you can use that gateway in the star topology. So LoRaWAN supports star topology. You can use mesh static that doesn't need any any gateway. So just with the everything can start to go. This thing supports the mesh network, and you can just go with it. This unit this unit, you are basically using a single channel for the communication. But what advantage you are getting in the LoRaWAN is that you are using like a band of channels that you are available to you. Full band you are utilizing. There are multiple channels available in that, and to basically overcome the congestion and collisions at a time, they have the something called listen before talk, and these kind of algorithms are available so that congestion can be avoided. The next part I want to move on is security. So as I explained that in the LoRaWAN, they use some encryption so that even you use a public gateway, that code that you are sending. For example, in this whatsoever we are sending like packet hello or something, if that is something very critical to me, then I can use the encryption or crypto accelerated block of the hardware. So these blocks are I will also show you in introduction. So if you see, there are hardware cryptographic accelerators available on this silicon fabric. So we use these hardware accelerators to basically do the encryption and decryption of the data at the hardware level. By doing that at hardware level, we get so much of the speed. So that if you want to do that kind of encryption in the software part of it, that is way too slow and even not supported. So this is the major improvement from, if you see the 8266, ESP8266 and ESP32, if you compare that. So these are the major improvement that is done for the Internet of Things use case scenarios, in which we have the cryptographic block at the hardware level, so that we just pass the cipher text and we just pass the key, and it just give us the decrypted text. And so I will just demonstrate by an example of ECD mode of encryption and decryption. So this is a simple example. Again, I have provided the code. So in this encryption, you can see that I'm just using this library, and I have made two kind of functions, one to the encrypt and one to the decrypt. So for example, if my key for this ECD mode is this ABCD something, and I want to basically encrypt this text. So whatever my data is, critical data is, I will just place it over here. Currently, I have just used my secret keyword. So I have just used it, and you can see that I have basically cipher text. I have basically encrypted it using this encrypt function. So you can see over here, I've basically made a variable, and on the text output variable, I have just saved that part, and I'm just printing that save cipher text output uh, to basically print it on the serial. So my raw critical data, my secret, is being converted to my ciphertext, and that ciphertext, from that ciphertext on the receiving end, I can also use this cryptographic decrypt function to basically decrypt that particular thing with the same key and print it over here. So one part can use this encryption part, another part will use the decryption part, and you will have this secure communication from one end to another end. This is the major bottleneck when we talk of this part ESP8266, but this is a major improvement in this ESP32, and this is the bare minimum required by the devices that support the security unit security features. So if you want to communicate these kind of devices to the AWS IoT core, for example, so then that whatever the PAM file or the keys, SHA keys, or the security module that they provide, we need for the communication. We need these kinds of blocks to basically maintain a secure TLS communication and decrypt and encrypt using these accelerated cryptographic blocks. So these blocks is being used by the secure connection for packet to receive and to send. So this is a basic example. Okay, so 5 minutes are more. Okay, so next we will see the network discovery. So yesterday we saw how two devices can discover itself within a network, or how we can basically find a device. Suppose whenever a device is basically up, so I don't know what its IP is. So IP is being allocated by the DHCP server within our router. So that DHCP has certain release time on after which the device will get a new IP if it is not connected for the long, and if it connect after very big time, then it can receive any IP. So in that scenario, basically I need certain protocol or certain features so that my two devices can basically find each other very easily, so that my device one can send the data to the device two. I need not to find the IP every time. It is a very cumbersome process. If you see, every time I'm going to my router page and finding the IP. So there is an discovery protocol you can basically use, like MDNS. It is a multicast DNS service. So what DNS is, basically DNS keeps the mapping of the your domain name with the IP. And in the current scenario, in the current example, I don't want to know the IP by looking into the router page. So what I will do, I will, while writing the firmware, I will give it a domain. And since we don't have any, DNS resolving services like in the router, in the Google scenario, if you have used this 8.8.8.8, this IP for DNS resolution. So that is some server basically that resolves whatever subdomain or domain you provide to it, and it will give you the IP, what is the current IP at which it is located. So there is a similar thing in this embedded devices that you can do, in which you can use the Bonjour Hawaii. Hawaii is the basically open source Linux based software, and this is being open source later on. Earlier, Apple is used to use this in their devices for the easy discovery. Like if you from the Apple MacBook Mac, if you want to connect to the iPod, or what is the how where the printer is, which IP printer is, if you want to find that kind of devices, so you can use this Bonjour in the Apple, and in this making this public, they use the name Hawaii and these things. And you can basically, what you can do while writing the code, you basically initialize the MDNS service. On the MDNS service, you will mention that my name is this. You can write any name, for example, temperature data logger dot local, maybe temperature data logger, whatever thing that device is doing. So that is being mentioned over here. Whatever name you will write over here, it will be displayed in that network by that name. So on the Windows, you have to install the Bonjour. On the Linux, you don't have to as such install anything, because it is a pre-installed package in many platforms of Arch Linux and many other. In Ubuntu, you might need to install it. So it is readily package available. You have to just use the Hawaii to just install that thing. And once you will install that, you can basically use this particular code to do something like this. Basically, on the browser, you just type esp32.local, and it will just find that it resolve that domain with respect to IP, and it will automatically connect to your IP. So I'm doing it in the Windows. So for that, I have installed this package Bonjour. And if you are doing in Linux, you have to install Hawaii. So in this manner, you can easily communicate from one device to another. You can send one device data to another device, and you need not to know the IP of that. And from the multiple uh, data points, you can basically do something useful. It depends from use case to use case and application to application how you will use that. But this is one of the mechanism in which you can discover the device within your network without relying on the router. So this is a very simple code, and library is also provided to you. So we are basically first connecting to the Wi-Fi, and thereafter we are using MDNS package that is available in the Arduino framework. And this client is just for the showing the web page, nothing else. Main, this for the connecting Wi-Fi, this for the discovery part, this is for the returning of HTML page that yes, we are connected for this code. If you see that this page is written by that particular header library, using that library. And if you use some DNS resolving applications, so it will resolve you, give you this kind of output. So if you can see that for the printer, for the Microsoft normal computer, for some kind scanning. So these are the automation devices that I placed in my home. So this kind of discovery can be easily done, even though after restart or something, that IP might change, but it will not change the final integration of device to device communication. So it can easily discover the device, and it can start communicating and connecting from that. So these are all things. There are more topics. I think we don't have much time. So if there is any doubt or any application part of it that is required more clarity, you can please ask the question, or you can email it to me on mrityunjay.in@gmail.com for further clarification or any help or anything needed. You can please ask any question if you have any question. So you can just check it. If you have any question, you can basically ask, and you can unmute your mic if you have any question and you can ask. So these are all the features that we can basically perform from this board. So the main agenda of using that board was getting the various aspects of the IoT, the security aspect, the network topology aspect, the various network interface aspect, the embedded aspect, how to interface any kind of sensor to it, and these kind of examples and frameworks to help some advanced user can go to the ESP IDF, that is again the higher level function. So in all our example, we basically took this example on the easier Arduino framework. So some advanced use cases and developments can also take the ESP IDF into consideration, and that is some future topic, maybe something else we can. I will also share it on this blog or page if you can follow. And for this hardware, if anyone is interested, they can basically, this link is also available in the downside. They can explore it over there. And any kind of doubt, any kind of help in anything, you can just contact me. I just also write my contacting address. Just a second. So it's my email ID, and that's my number in case any help is needed or any there is any doubt. So if there is any question, you can please ask, or we can conclude if there is no doubt.
If anyone is having any doubt, so one can ask through unmute herself or himself, or you can write in the chat box. And also later on, you can mail to sir if you have any query. So thank you very much, sir. If there will be any query, come to me, then I will definitely mail to you. So thank you very much for your demonstration, live demonstration of IoT platform with real examples. So I'm sure all the participants will get benefited through your lecture. So thank you very much, sir. Thank you.
Thank you, sir. Thank you for providing this opportunity. Thank you, everyone. Thank you, sir.
So all the participants, you can just leave the meeting now, as the second session for today's will be from 2 onwards, and it is going to be very interesting session. So till then, you can just disconnect or leave the meeting. Thank you. Thank you very much.